Calibrates. We all love them. But isn't it kind of tiresome to, over every single surface, you have to put your robot over a white space, press the enter, and then you have to put it over a black space and press the enter again, right? That's super frustrating to do. So what if we could write a program that just automatically does it for you? It has your robot just drive across the line and find the highest and lowest values to plug into your variables by itself. Well, in this episode, we're going to be writing one of those programs and making your FLL life so much easier. So I actually pre-recorded this program and I'm going to explain briefly how it works. So as I press the button or start the program, the robot's going to drive over like this. And as it's going, the color sensor is always turned on. As it's turned on, you can see that when it's over a white area, it's going to pick up values above 80, let's just say. And when it passes over black, it's going to pick up values, say, below 20. What it does is it sorts those numbers and it finds and keeps the very highest value of reflected light intensity for white and the very lowest one for black. And it saves those two to our variables only. Now, if we compare this to our old Calibrate program, which is here, and we put the robot over a white area, but let's just say we put it over a little bit of black too, we get a value of 80. Whereas if we put it perfectly over white, we might get a value of, say, 100 right here. What this new program does, besides making it easier for you to calibrate properly, is it finds the very highest and the very lowest of your values, saves it, and that makes your robot a lot more consistent under any lighting circumstances. So let's go to the computer and try to write this program. You might remember last time we wrote this Calibrate program. And what this does is you have to actually pick it up and you have to press the center button in order to measure the values. Well, what if we could make it fully automatic calibrate? So you set it down anywhere, and as long as you know the robot will cross black and white, it will automatically set the exact value or the highest value for white and the lowest value for black into your program. Well, luckily for that, we have a Calibrate just for that purpose. Let's start writing this program. Before we begin though, I'd like to highlight a key portion from this program that we didn't necessarily need to focus on, but now we do. It's the high and low portions. So here, you only get to replace the high and lows once, but in our new program, what it looks like is it looks like this. So it's going to continuously, within a period of time, be updating the values or variables. So in our new program that I've already created, we're similarly going to set up the same variables, which are high and low. We're just going to use high and low for this program. And normally high goes on a scale from 0 to 100. And usually it's on the higher side, right? I'm just going to say it's around 100 here. And similarly, low is going to be on the low spectrum here, 0. So now how the Calibrate program in and of itself works is it tries to find the highest high value and the lowest low value. So in this case, our highest high value obviously is going to be as close to 100 as possible. So the highest number we can see. And the lowest of the lows is going to be the lowest number that we see, obviously. So as we're rolling across, we actually set high to 0 and we start low at 100. So this way, if we were to take our measurements, so let's just say our measurement is 45 at like the first second, at a specific 1 second interval, it's 45. Now this value is going to be higher than 0, so it plugs that 45 into high. It's also going to be lower than the low value, and it's going to plug it in into low as well. So now high and low are both 45. However, let's say like 0.1 seconds later, we see a value of 60. Now, that 60 is higher than a value of 45, so high will be replaced with a value of 60. And low will not be replaced because we're looking for the lowest number. And out of 45 and 60, of course, 45 is the lowest number. So this might not make as much sense to you now, but as we start writing, you'll get accustomed to it eventually. So besides the variable setup, which we have handled here, what did you notice in that program? The first thing and most obvious thing is the drive forward, and our drive forward is a very smooth drive forward. So what you do here is you add a move tank and you just turn it on. And the speed 50 is actually too high for the color sensor to accurately pick up all of the colors. I personally use 20 and different lighting circumstances, or if your color sensor is working weirdly, you can up or lower the speed depending on your preference, but I'm just going to choose to use 20 for now. Next, the thing, because when we're driving forward, the color sensor is continuously going to be picking up values, we're of course going to need a loop block. Now, I have it set to seconds. So what this does is you can basically place it over anywhere and it will run for 2 seconds. There's another option though where you can use the motor rotation, and you turn it to rotations, and let's just say I want it to go 1 rotation or 1.5 rotations. How about that? As soon as it becomes greater than 1.5 rotations, it's gonna stop. It's gonna cut the loop. And at the very end, we're gonna add a stop drive block, just so like we can stop the program cleanly and then save the values. Next, we're gonna need the read function. So normally, if we drag out the read block and we set it to reflected light intensity, it only really measures it once. However, if we put it in this loop, because this has a runtime, or the sensor read block has a runtime of almost no time at all. So like, let's just say it's 1 millisecond. In reality, it might be around this value. This loop basically makes it loop infinitely, so it will always be detecting values. So we're going to plug this value and we're going to read the function, and we're going to compare it to the current high value for now. So what you go here is you go to the data operations block and you go to the compare block. Now the compare block is a greater than or less than sign here, and let's just drag over a high. So at this current moment, our high is at a value of 0. We're going to read the numeric sign here. Plug both of them in. I'd recommend you plug, in order to follow along with this tutorial, plug in the color sensor reading into A and plug the high variable into B. And here you can change equal to greater than, less than, greater than, equal to, etc. Like, all of these options are available for you. Now, we want to find the highest value. So we're going to see whether the new value is higher than all other values it has seen before. So we want the current read color sensor to be higher than our high variable. So of course we're going to put it as greater than. So in the event that the color sensor reading is higher than the current high variable, this logic output is going to be true. Next, we're going to put a switch, because we want the robot to make a decision about whether or not to plug in the value or not. So put in a logic, and you're just going to plug it in. Now, in the instance where we actually have to do something, where we have to plug in this new value into the high variable, this logic block is going to be true. Like, in the only instance where we're going to change anything in our program or change the value of the high variable is if this is going to be higher than the current high variable. So this is going to be true. So the only place we're going to be putting any blocks is the true area. Swap it to tab view because it's just easier to link stuff in, and you're going to drag in a high block. Now what this high block does is you can just rewrite the high variable. So because at this specific instance, at like this loop number, so let's just assume this loop number is like the first loop that you went through. So only a millisecond has passed, keep in mind. At this specific millisecond, so let's just say 1 millisecond after you start the program, it's going to replace your high variable. So take the current color sensor reading value and plug it in to here. You should be able to do that as long as you're in tab view. If you're in flat view, you can't actually do that. So make sure it's in tab view. Great, so now you have your high variable set up. I'm going to go check whether or not this is true and whether or not it works. And how you can do this as well is you can drag your variables to the back, set it to read numeric, make sure it's high. And then at the very end, because you're cutting off the program at 1.5 rotations, you also want to add our my block, wait for bumped. And this allows you to check the values. So I'm going to run my robot from my computer, and you should be able to see the robot from the bottom left corner. And if we pull up the value for high, we can see that it's 95. This means the highest value it has seen on white is 95. And that gives us a more accurate representation of just hoping that the white we're currently on shows a 95. Now, let's move on to doing the exact same thing but for the low variable, just so we can have both of them and we can actually get the mid value in order to use in our line follow or line square, whatever other program we want to use these values for. Now we're going to do this by essentially taking the same program and copying it over once. There's going to be a few changes, however, in this because, of course, we're not doing it exactly for the high variable. We're going to change it around. So now instead of we want it to be greater than the high variable, which is right here, we want it to be lower than the low variable. So what we're going to do is, of course, we're going to change these variables to low. And now we want to compare if it's less than. So now in the instance that low is lower, or the lowest number that we can find, we're going to plug it into a true box, and we're going to replace the variable. This is all you have to change from the original program. And so now we have basically our Calibrate. Now if you run the program and we can check it out in real life, we can see the values right here. Now as the robot's running, we can check the values. So I'm going to check the high first by dragging it out, and we see it's 100, which is completely fine. That's the high value that we normally got from our other Calibrate as well. Now let's check the low, and our low is now a 2, which is also perfectly reasonable. By doing this and checking the variables afterward, you can essentially tell if your robot's Calibrate has worked properly. And now we're waiting for a break button pressed. I'm going to press it, and the program's done. So now you have your saved variables within your entire project. And this Calibrate is automatic. You can change the number of rotations that you have in your loop. And essentially, it's an easy Calibrate that you can press a button. It automatically does everything for you. All you have to do is start the program. Thank you all for watching another episode of my FLL must-have series. In the next series, I'm going to tell you how to share those values and save it on your computer using the file access code. So until next time, bye-bye.